moving on into chapter 9. In case these videos have been a bit boring for you, yeah, I get it. It's a bit boring for me as well. But I feel like it's a fruitful endeavor for myself in terms of trying to help other juniors about. By the way, if you are a junior dev and want like to just talk, I'm more than willing to have a discussion. Feel free to just drop a comment, I guess, and then we'll take it from there. In terms of how do I reach out to you, I don't actually know, but yeah, maybe I should just add my contact details in my YouTube stuff. I don't know. We'll see. We'll see how that goes. Alrighty. Chapter 9. So this chapter is all about the lists, aka the good stuff, the really, really good stuff. It's not. Anyways, lists. This chapter presents one of Python's most useful built-in types, lists. You will also learn more about objects and what can happen when multiple variables refer to the same object. In the exercises at the end of the chapter, we'll make a word list and use it to search for special words like palindromes and anagrams. A list is a sequence, like a string, you know? I kind of already brought this up in the previous video, but yeah. A list is a sequence of values. In a string, the values are characters. In a list, they can be any type. The values in a list are called elements. There are several ways to create a new list. The simplest is to enclose the elements in square brackets. For example, here's a list of 2 integers, boom. And here's a list of 3 strings. The elements of a list don't have to be the same type. The following list contains a string, a float, an integer, and even another list. Yep, that's accurate. Lists don't need to be singly typed, as is true of most of the generics. So a small aside, these types that aren't like fundamental types like int, float, string, they're called generics. And I think the reason they're called generics is because they are a type, but they contain other types, essentially, right? Which is true of if you were to try to create your own type, 9 times out of 10 it'll be generic. Maybe you want to have a more strict definition for a specific type of string. You could create a class that's URL string, and that entire class is all about just ensuring that the string you provided is a valid URL, and then manipulating things with manipulating the URL in a specific way, which would essentially be a type of string. So that wouldn't be considered a generic, I think, or maybe it would. I don't know. Maybe it would, because it contains a string type and probably other types that make the whole magic work. So I'm not sure. A list within another list is nested. Yeah, so whenever you have a list within something else, it's considered a nested list. And nesting is just like, it's exactly what it sounds like. It's just like a Russian doll. So if you have a for loop within a for loop, or just any loop within a loop, you have a nested loop. If you have a conditional within another conditional, that's a nested conditional, etc., etc. Okay. A list that contains no elements is called an empty list. You can create one with empty brackets, boom, right there. And the len function returns the length of a list, just as it did with strings. It does it with any sequence, really, except for, I think, generators, which it's an iterable, but it's not a sequence, I believe, because an iterable doesn't need to have a defined end. An iterable doesn't need to have a defined end. Yeah, correct. But a sequence does, right? And sequence needs to be indexable, right? Which is not true of generators. But this is a completely random aside. I feel like I'm doing a terrible job for people who are actually beginners. And I apologize for that. I don't know what to call this whole exercise, because I think it's not that anyone's regularly watching, but if anyone is or begins and tries to like watch my whole saga, it's not the case. Anyways, len empty 0. The length of an empty list is 0. Yeah, there you go. The following figure shows the state diagram for cheeses, numbers, and empty. Another state diagram. Yeah, it's just a state diagram showcasing these different lists we created. Lists are mutable. To read an element of a list, we can use the bracket operator. The index of the first element is 0, just like with strings. But unlike strings, lists are mutable. We talked about this in the previous episode. When the bracket operator appears on the left side of an assignment, it identifies the element of the list that will be assigned. So now you switch numbers 1, aka the second element in the list numbers, to 17, and if you print it out, and that is exactly what has happened. Second element of numbers, which used to be 1 to 3, is now 17. List indices work the same way as string indices. An integer expression can be used as an index. If you try to read or write an element that does not exist, you get an index error. If an index has a negative value, it counts backwards from the end of the list. The in operator works on lists. It checks whether a given element appears anywhere in the list. So yeah, pretty much standard stuff, same thing as with strings. Except just when you use the in operator, it doesn't just look for like a sequence of strings, it looks specifically for a specific element. All right? Like whether Edam is in cheeses or when's Ladale. I don't know whatever that is. Although lists can contain another list, the nested list still counts as a single element. So in the following list, there are only 4 elements. 1, 2, 3, 4. Yep, that's correct. And 10 is not considered to be an element of T because it is an element of a nested list, not T. Correct. So, I mean, if you wanted to actually get that nested list, you'd have to go 10, 20, and then that would evaluate. Would that evaluate to true even if it's... Yeah, okay, no. It does actually look at the elements inside the list. I wasn't sure if it just did a shallow check or a proper check. List slices. The slice operator works on lists the same way. Is my recording? Yeah, okay. From that one time, there was one time I lost like a huge recording, and I've been a bit paranoid about my recording since then. It seems super weird to you guys because I've set it to hide the recording software, but yeah. List slices. The slice operator works on the list the same way it works on strings. The following example selects the second and third elements from a list of 4 letters. So that should be, yeah, B and C. So the element at index 2, or the second index, which is index 1, or the third index, which is index 2. So that's what you get, PC. Just like with slicing with strings, it's basically all the same stuff. If you omit the first, it begins at if you omit the first half of the slice, it starts from the beginning. If you omit the second half, it goes all the way to the end. If you omit both, it's the whole thing. Another way to copy a list is list letters. Because list is the name of a built-in function, you should avoid using it as a variable name. True. So another thing about this that will probably catch someone off guard, so I'm just going to go ahead and show it to you. Let's say, where's the one with the nested list? Yeah, okay, so I'm just going to go ahead and copy that really quickly. I just want to show this to you guys, right? So, and then if I create new T equals list T, right? And then I go new underscore T -1 0 equals 0. So basically what I'm doing, this is known as chained indexing. So I index the top level list new T and take the last element, which would be this. So new T is the same as, as this list over here initially. And then I take the last element of this new list, which is another list, right? So I can then index into that list. So that's why the chained indexing, it's an index on an index. And take the first element in that list and change it. And then if I print T again, you're going to see something special. Boom. Even though we only changed new T, I didn't change the first one. Even though I only changed new T, it changes the first one. But if, for example, I also change the first variable, not new 2, new T equals spam. Oh, ham. I'm just going to go call it ham. But if I run this, it doesn't change anything. Why? Because the objects or the elements within a list, even if you create a new list, and to create a new list that is a copy of another list, you have to do this, or you can do dot copy or dot deep copy, something like that. And the reason for that is the elements inside of a list, even if you like assign that list to a different variable or something like that, to try and take a copy of it, the elements in that list will still refer to the original object. So the original object, if you change something, an element from in the new list, which you got not by using the list keyword, but by just assigning it to a different variable, it'll actually change the original list as well, right? Now, when you do list or dot copy or dot deep copy, it technically creates a copy of the list, but if there are nested lists within that, it only does like it actually doesn't change the reference point for the nested list. So that's like a neat little thing that's kind of important actually. Okay, so because list is the same built-in function, you should avoid using this. Okay, you already read that. List operations. The plus operator concatenates list just like a string. T1 plus T2 will be 1, 2, 3, 4. The star operator repeats a list a given number of times. So spam. Actually, does that work with spam? And I'm gonna double check this. Yeah, okay, it does. I wasn't sure about that. Anyways, no other mathematical operators will work with lists, but the built-in function sum adds up the elements, and min and max find the smallest and largest arguments. I think that only works if they're all numeric type, but I'm not sure about that. List methods. Python provides methods that operate on lists. For example, append adds a new element to the end of the list and it adds it in place. So, letters is created and then you do dot append. You don't have to assign that again. It just does it right there, right? You don't have to go letters dot append e and then assign the return value to something else. These methods don't return anything, but they do update the list in place. Extend takes a list as an argument and appends all the elements. Letters dot extend fg letters. There you go. So basically, t.pop, there are two methods that remove elements from a list. If you know the index of the element you want, you can use pop. So yeah, that will just pop off a particular element. And if you just do pop, I think it'll just pop the last element on the list. Return value is the element that was removed, and we can confirm that the list has been modified. So if you just print TAC, there you go. If you know the element you want to remove but not the index, you can use remove, also true. And this will also remove the value at the same time, as you can see here. The element you ask for is not on the list, that's a value error, right? Okay, so you're gonna wanna wrap that in a try except block, which you may or may not know about. We've done it a few times here, but yeah. Lists and strings. A string is a sequence of characters and a list is a sequence of values, but a list of characters is not the same as a string. To convert from a string to a list of characters, you can use the list function. Boom, like so. And you can do that with many types of sequences. Any type of sequence can be converted to a list like this. The list function breaks a string into individual letters. If you want to break a string into words, you can use the split method. So the split method is a string method, right? Not a list method, but then when you do it, it gives you a string that splits out the spaces. And I'm pretty sure split can take some arguments where you can change the separator, which is default space. An optional argument called delimiter specifies which characters to use as word boundaries. The following example they just go right into that s.split. So x-parrot will become x-parrot as a list. There you go. If you have a list of strings, you can concatenate them into a string using join. Join is a string method, so you have to invoke it on the delimiter and pass the list as an argument. Yeah, so that's a weird one, but yes, that one's thrown me up so many times because I'd be like in my head, I'm like, oh, I'm just gonna join this, and I try to do it on the list, and I'm like, god damn it, how do you do this again? I've had to look it up like so many times. It's so annoying. Um, but yeah, so basically, join is also another string method, but then that method essentially takes a list and joins it based on the delimiter that you use, right? So the delimiter is the string, and then you use the join method with that string. Um, anyways, in this case, the delimiter is a space character, so join puts a space between words. To join strings without spaces, you can use the empty string as a delimiter. Looping through a list. You can use a for statement to loop through the elements of a list. For example, after using split to make a list of words, we can use a for loop for to loop. We can use for to loop through them. Okay, that was just worded weird. Yeah, so you can just do for word and s.split and then print each word. A for loop over an empty list never runs the indented statements because there's nothing to iterate over. Sorting lists. Python provides a built-in function called sorted that sorts the elements of a list. There you go. That's true. Original list is unchanged, so sorted actually returns a new list. Sort works with any kind of sequence, not just lists, so we can use letters in a string like this. So strings are also a sequence. Remember that. The result is a list. To convert the list to a string, we can use join. So yeah, that's not very useful in this particular case, but we can. With an empty string as the delimiter, the elements of the list are joined with nothing between them. Yeah, there you go. Objects and values. If you run these assignment statements, a equals banana and b equals, we know that a and b both refer to a string, but we don't know whether they refer to the same string. There are two possible states shown in the following figure. A is banana and b is banana, or a and b both point to banana. In the diagram on the left, a and b refer to two different objects that have the same value. In the diagram on the right, they refer to the same object. To check whether two variables refer to the same object, you can use the is operator. I think this would be false. Oh, it is true. Oh, okay. This example, Python only created one string object and both A and B refer to it, but when you create two lists, you get two objects. Yeah. So state diagram looks like this. Yeah. So, okay, I did not know about the whole string thing. I didn't know that they would refer to the same object. That's kind of mind-blowing to me. I didn't know it did. Python did that. But yeah, essentially, every time you create one, it's created separately, right? But remember, and I'm pretty sure this is what they're going to be talking about in a moment. But remember what I said earlier about how the elements of the list then refer to the same thing. So if you rename the list and just assign it to a different variable or whatever, and then do some operations on it, you're changing the original list as well. It's the same list. So yeah, lists are kind of funkadelic like that. In this case, we would say that the two lists are equivalent because they have the same elements, but not identical because they're not the same object. If two objects are identical, they are also equivalent. But if they are equivalent, they are not necessarily identical. So it's essentially saying like, okay, the easiest way to explain this is like twins, right? Twins are identical, are equivalent, aka they are the same, but they're not identical. They're not the same person. And I know that sounds weird because like you hear the term twins, you usually think identical twins, right? It's a bit of a semantics thing. You could flip around those words and use identical and equivalent separately. But basically, it's like if I have twins, it's not the same person pretending to be two people, right? It's two distinct people, even though they look and talk and act essentially the same. So that's what this sentence is really trying to explain. I don't know what that weird highlighting thing was. Aliasing. If A refers to an object and you assign B equals A, then both variables refer to the same object. Boom, right there. So the state diagram looks like this. Okay, another diagram, which, yep, right there. The association of a variable with an object is called a reference. In this example, there are two references to the same object. An object with more than one reference has more than one name. So we say the object is aliased. If the aliased object is mutable, changes made with one name affect the other. In this example, if we change the object B, if we change what the object B refers to, we are also changing the object A, what object A refers to. So yeah, this is kind of what I showcased a little bit earlier. If you change it in B, you can see the changes in A. But it won't work if you did, for example, list A, because that actually creates a new copy, right? All this works because we actually just assigned A to B, right? If we did list dot, I think it's dot copy, there you go, right? Or if you do list, right, like that in the assignment for B, then there would be two different things. But right now it's the same reference. They both reference the same thing. Anyways, B0 equals 5A. So we would say that A sees this change. Although this behavior can be useful, it is error prone. In general, it is safer to avoid aliasing when you're working with mutable objects. So yeah, for immutable objects like strings, aliasing is not as much of a problem. Almost never makes a difference whether A and B refer to the same string or not. Yeah, so that makes so much more sense why these two refer to the same thing, because they're immutable. Okay. Yeah. And 9 times out of 10, you're not gonna write out the same string twice or the same, like, yeah, that makes actually a lot of sense. So yeah, because this is stuff that you actually have to do very explicitly in certain other languages. Not in Java, I don't think so, because Java at least used to have a huge issue with memory leaks and stuff. But I think it's in C and C++, you have to do this like manually, and it's terrifying, honestly, for someone like me, because I'm just like, oh god, C++, I have to manually manage the memory. I have to deallocate references. What? Yeah, Python usually does all this magic in the background, which is why it's actually important that they're bringing this up, because it's very easy. The syntax of Python is super easy. It's super duper easy. But to actually start building stuff, these concepts matter. Anyways, it's so weird in this whole journey. Like, I started with one thing of like learn by doing, and that's the only thing, right? And I think just observing myself and all the things I've had to do, it's actually a mixed bag of a lot of different things, right? To properly actually learn it, not like learn it to pass a test. That's different. Yeah. Anyways, list arguments. When you pass a list to a function, the function gets a reference to the list. If the function modifies the list, the caller sees the change. For example, pop first uses the list method to pop to remove the first element from the list. Yeah, so this would actually, if you do this, whatever list you pass in will actually be modified in place, right? And then if you check letters, boom, right there, BC, as they said. Another stupid state diagram. In this example, the parameter list and the variable letters are aliases for the same object, so the state diagram looks like this, boom. Passing a reference to an object as an argument to a function creates a form of aliasing. If the function modifies the object, those changes persist after the function is done. True. So yeah, be careful when you're working with mutable types, especially in Python. Making a word list. In the previous chapter, we read the file words.txt and searched for words with certain properties, like using the letter E. That was actually 2 chapters ago. I'm assuming that chapter 8 was an addition to a later edition of the book, and they just never updated this. Very possible. Word list. Okay. Before the loop, word list is initialized with an empty list. Each time through the loop, the append method adds a word to the end. When the loop is done, there are more than 113,000 words in the list. Another way to do the same thing is to use read to read the entire file into a string. String equals open words.txt.read. Len string. The result is a single string with more than 1,000,000 characters. We can use the split method to split it into a list of words. Word list equals string.split. Len word list. I'm just reading things out at this point. The results is a single string with more than 1,000,000 characters. We can use the split method to split it into a list of words. Yeah, okay. So this is just showcasing that you can just do dot read after open, and you can assign that to a string, but that'll just attach everything as a string, and then you can split that string over here with len word list. Now to check whether a string appears in the list, we can use the in operator. For example, demotic is in the list, true, but contrafibularities is not. I don't even know where these people get these words. I think this guy's just like super into Monty Python, and I think these are all like Monty Python references or something. Debugging. Oh, okay, so we're almost at the end of this chapter. Note that most list methods modify the argument and return none. This is the opposite of the string methods, which return a new string and leave the original alone. If you're used to writing code like this, word equals plumage, word equals word.strip, exclamation point, word. It's tempting to write code like this, but that won't do anything because this method doesn't return anything. So t equals none. And what you actually end up doing in this one, and why it's wrong, is because unlike in this case with strings, because it's an immutable type, its methods return a new string. It's not actually the same string, right? So it's a brand new object. Here, lists don't do that. Lists will modify in place, and methods that modify in place don't return anything. It just returns none, N-O-N-E, or null, which is another term for the same concept of nothingness, I guess. And so when you do this, what actually happens is, because this method remove has no return type, implicitly it returns none, and you assign none, N-O-N-E, to t, and you actually lose your reference to the original object. Even though it may continue to exist, you have no reference to it, so you can never get it back again, and it will get garbage collected by Python. So it removes, modifies, and returns none. So next operation in performance T is likely to fail. So yeah, this is exactly what I just said, and you get an attribute error for that. None type object has no attribute remove. So attribute error is essentially anytime you're trying to access an attribute, which a method is a type of attribute, and it doesn't exist, you get an attribute error. The standard error message takes some explaining. An attribute of an object is a variable or method associated with this. In this case, the value of t is none, which is a none type object, which does not have attribute name removed, so the result is an attribute error. If you see an error message like this, you should look backwards through the program and see if you might have called a list method incorrectly. Yeah, fair. Your glossary, beautiful. Exercises. And antiseptic, but they're not. They were used in the British television show Blackadder season 3 episode 2. Okay, so this was a Blackadder represent. However, ChatGPT where those words came from. It initially claimed they're from Monty Python and later claimed they're from Tom Stoppard play Rosencrantz. Okay, if you ask now, you might get different results, but this example is that virtual assistant. Yeah, they're not. As you gain experience, you'll get a sense of which questions virtual assistants can answer reliably. In this example, a conventional web search can identify the source of these words quickly. If you get stuck on any exercises in this chapter, consider asking a virtual assistant for help. If you get a result, blah, blah, blah. For example, before you ask a question, try typing role basic Python instructor. After that, the response is you should use only basic features. If you still see features we haven't learned, you can follow up with, can you write that using only basic Python features? Yeah, true. Two words are anagrams if you can rearrange the letters from one to another. For example, toss an anagram of stop. One way to check whether two words are anagrams, sort the letters in both words. If the list of sorted letters are the same, the words are anagrams. Write a function called isAnagram that takes the two strings and returns true if they're anagrams. Get you started. Here's an okay, yeah. So some fun. You can use doc test to test your function. Yeah, that's some good stuff that we learned a few chapters ago, but it is good stuff. Python provides built-in function called reverse that takes an argument, a sequence of elements like a list or string, and returns a reversed object that contains the elements in reverse order. If you want the reversed elements in a list, you can use the list function, or if you want them in a string, you can use the join method. So you can write a function that reverses a word like this. A palindrome is a word that is spelled the same backward and forward like noon and rotator. Write a function called isPalindrome that takes string argument and returns true if it is a palindrome and false otherwise. Okay, so more stringy stuff. Write functions called reverse something that takes an argument string that consists of any number of words separated by it should return a new string that contains the same words in reverse order. For example, if the argument is reverse the sentence, the result should be sentence this reverse. Hint, you can use the capitalize method to capitalize the first word and convert the other words to lowercase. Blah blah blah. Write a function called total length that takes a list of string and returns the total length of strings. The total length of the words and word list should be 902,728. Okay, so that's the end of this video. I need to like rush to the bathroom, but once again, good exercises. If you're a beginner, please definitely do them. All right, bye. Take care. Bye.